Bienvenidos, Hushamdi, and welcome to this HUD 8 techtorial on Cisco Networking Academy's new Enterprise Networking, Security, and Automation course that's part of the CCNA version 7 curriculum that was just released a few weeks ago. In this techtorial, we're going to be focusing on Packet Tracer Activity 2.6.6, where we're going to be verifying Single-Area OSPFv2. So what are you going to be learning about in this activity? Well, you're going to learn and see all of the commands that will add value to your role as a network engineer in an OSPFv2 environment. We're also going to be connecting a router 4, to the topology that already exists. Now, let's go ahead and dive in and take a look at the topology that we'll be working with here on the top left-hand corner of the screen. Now, the top of the topology should look familiar. That's the topology we've been working with recently, minus the internet web server. And what we have now is we have this branch office LAN, or local area network, where we've got a laptop using wireless connectivity over here to the access point, connected to a switch and then to router 4. But you'll notice that router 4 is not connected to the rest of the branch office network. So that's going to be part of the work that we do. So here's the activity packet tracer addressing table. And let's now move down to the instructions. It says verify the existing OSPFv2 network operation. The following commands are going to help us. Now, all of these commands are critical commands for your OSPF toolbox. And they're going to make things a lot easier to validate and verify as we work our way through this activity. So let's go to step number 1. It says verify OSPFv2 operation. Now, we're going to log on to router 1 and jump onto the CLI, or the command line interface, and we're going to be using the username branch admin and the password branch1234. And that's going to get us into privilege exec mode. So let's say show IP route. Now, all of this output should look very, very familiar. We're receiving that default route via OSPF, which is why we see it as an OE2. If you're interested in the difference between an OE2 and an OE1, I recommend you go back and take a look at Packet Tracer Activity 2.5.3, which precedes this activity. Now, we see that we have this default route that we've learned via OSPF, and then we see this other routing information. Now, if I wanted to trim this down, could I say show IP route OSPF? If I only wanted to see the OSPF learned routing information that router 1 is seeing. And this makes it a little easier to look at from an OSPF perspective. Now, one of the things I want to draw your attention to is the network of the branch office LAN here, and specifically the 192.168.11.0/24. When we examine the routing table here on router 1, do you see a specific match for that network and subnet mask length? And the answer is no, we don't. Right? So router 1 right now has no way to reach any of the networking gear here behind router 4. And you're probably looking and saying, well, there's no connection here. Well, we're going to go ahead and solve that shortly, but I just want to draw to your attention that router 1 does not see any way and has no route to get to the 192.168.11.0. Now, we've got some questions here. How did router 1 receive the default route? Excuse me, again, from Packet Tracer 2.5.3, where we took a look at originating a default route. If this is my internet service provider network, router 2 is what we refer to as an autonomous system boundary router, or ASBR in OSPF, because it is originating information from outside the OSPF routing domain. So let's go ahead and take a look here and see how we would see that. I would say Branch admin is my username, and the password is branch1234. Now, if I say show IP OSPF, excuse me, I'm going to see quite a bit of information here. And you can see that we're part of the backbone area. And what if I was to say show IP protocols? Now, that's another command that can provide some interesting information for us. Now, when I say show IP protocols, you'll notice that right here, it says that this router is an autonomous system boundary router. It's an ASBR because it's redistributing external routes, and we get a from comma, but we know that it's redistributing. If I were to say show run, and it does not like that on router 2. That's interesting. What about show running? It does not like that either. How about a show IP route? All right, it doesn't like that show run command there on router 2. So maybe router 2's been limited in what it's going to be able to show us. But if we were to say show IP route, you can see that it's originating that static default route, and it's showing me that that is going to be the next hop. In other words, that's going to take us out to the ISP network. So that is how that default route is being originated. That is how router 1 and router 4 are router 3 are receiving that default route. From which router did router 1 receive the default route? Well, we can see here. It's interesting. Let me see if I can say show run section router OSPF. Yeah, it doesn't like, that's very interesting. It won't let me display the running config here. So, but again, we know that this is how it's being originated. If I was to come back to router 1, how would I know that it was being originated there? Because 172.16.3.2, which is router 2, that is where I'm learning it, and that is my outgoing interface. Again, we've seen that topology before, so we do have a little advantage knowing that that's how the information is being learned. All right, so how can you filter the output of the show IP route to show only routes learned via OSPF? And again, we saw that. It's just simply show me the IP routes that are only OSPF routes. And the same command, and let's see what they give us here. Yeah, the same command could be used if you only wanted to see BGP routes, or, pull that back, EIGRP routes, or RIP routes, right? That's what it would show you. And you can see we're getting some odd output here because there is no EIGRP and there is no RIP that's running. So we may be running into a little packet tracer anomaly here. But that command is a beautiful command to run, especially in an enterprise network where you may be looking at a router that has hundreds of routes on it, but you only want to see the OSPF routes, or you only want to see those BGP routes. So keep those commands close to your toolbox. Now, execute show IP OSPF neighbor on router 1. So here we are on router 1. Let me say show IP OSPF neighbor. And you can see that we are fully adjacent with both router 3 and router 2. Now, the priority value for the DR-BDR election is 0. Why? Exactly. That is the default priority value on a point-to-point OSPF network. And all of these serial links here between router 1 and 3, router 1 and 2, 2 and 1, and 2 and 3, those are all point-to-point interfaces. How could I see that? Show IP OSPF interface. Excuse me. And you can see right here, the network type is point-to-point for both the connection to router, I think that was router 3 down there, and this is router 2. So you can see type point-to-point. We can see the hello and the dead interval. We see that wait interval as well. So that is why we don't see, when the show IP OSPF neighbor command is run, the priority is going to be 0, the default for point-to-point interfaces, and that is also why here the state shows a dash. There is no DR-BDR election. None is required. Remember, the entire premise and purpose and reason for the DR and the BDR is scalability in a broadcast multi-access network like Ethernet, so that all routers do not need to become fully adjacent with all other routers. In a point-to-point network, there are only two things that are on that point-to-point segment, because there can only be two things. So it's going to be router 1 and router 2 here, router 1 and router 3 here. So we don't need the DR and the BDR because we don't need to take scalability into account. It is a point-to-point network. There will only ever be two things on that network. And so that's what we see there. Now, which routers have formed adjacencies? Router 2 and 3. What are the router IDs and the state of the routers shown in the output? Well, the router ID, it's quad 3 and quad 2, right? And those are probably loopback addresses on those routers. Now, the state is fully adjacent, but there is no DR and BDR. So using the command prompt on PC1, let's go ahead and let's ping, and we'll pull the desktop up. Let's ping the address of the ISP router shown in the addressing table. Is it successful? It says, if not, do a clear. Now, it says clear OSPF process, and we're going to see whether or not that command is available in addition to the clear IP OSPF process. So let's come up to the addressing table. It's going to be probably a 64 is my guess. And let's see, 64, 100, 54, 5. So the ISP router is going to be ping 64, 100, 54.5, and let's put a space in there. All right, so we may get a request timed out. There may be an ARP, an address resolution protocol packet, that needs to be sent because we have the layer 3 information, and this is what the ARP protocol facilitates for us with IPv4, is we have the layer 3 information, so I know who 64.100.54.5 is based off the layer 3 IP, but I don't have that layer 2 information that I need to forward the frame that's going to have these IP packets, these ICMP packets in there. So we send an ARP packet, so we time out, but we get our answer and we successfully make it out to the ISP router. So that worked without a problem. Now, verify OSPFv2 operation on router 2. So let's pull router 2 up here, and it's going to be interesting to see because that show run command is not working. So let's see what we need to validate here. It says log in. We did. How did router 2 learn the default route to the ISP? So that might be why we can't do show run. Maybe they are limiting what we can run here to force us to say show IP route and not let me look at the running config. And you can see here, we know exactly how it learned it. It was manually configured. The static default route has been manually configured on router 2. And then that route has been originated, advertised, propagated into the OSPF domain to routers 1 and 3. Very similar to the activity we did previously, 2.5.3, where we talked about propagating a default route into the OSPF routing domain. So it now wants me to enter in the show IP OSPF interface gigabit Ethernet 00 command. Now, that is the gig 00 interface here out to the 172.16.2.0/24 land that router 2 is connected to. Now, what is it asking us to check out? It says, what type of OSPF network is attached to this interface? Well, remember, this is a gigabit Ethernet interface. So it is a broadcast network. And let's see where they're going with this. It says, are OSPF hello packets being sent out this interface? And the answer is no. And remember, as a quick review, we don't have any OSPF speakers out that LAN interface. The same is true on router 1, and the same is true here on router 3. And the same would be true here on router 4. Out those interfaces, we don't need to send OSPF hello packets every 10 seconds Because one, we're not trying to locate any other OSPF speakers. We know they don't exist. And two, it is a security concern. We don't want the hello packets being broadcast or multicast out to 224.0.0.5, where a bad actor on PC1 or PC2 or any other PC connected to this LAN segment or these LAN segments who may be using Wireshark to capture those hello packets. And remember, the values in the hello packet are going to tell you what the OSPF domain is looking for in terms of OSPF speakers. You're going to see the router ID of the router sending that multicast packet. You're going to see the subnet mask length, the hello interval, the dead interval, all of those intervals that we saw in the previous videos that are going to be just enough for a bad actor to maybe start an OSPF process that has the same router ID as router 1, that advertises the same networks as router 2, right? And so that is where you can run into issues. So that's the reason, or a reason, that we use the passive interface command. Now, in addition to that, and what the text mentions and what one of the activities mentioned was, well, the overhead of devices having to process those packets. Well, I would put that into sort of the tertiary concern category, right? Behind the security concern and, excuse me, and behind common sense that we don't have OSPF speakers out there. So again, it definitely lowers the processing overhead that could be incurred by the devices that are out here on these LAN segments from having to process hello or see those hello packets. But remember, most importantly, it is a security concern. So that is why we passive interface all of those interfaces. Now, it is asking me, are all of the adjacent routers shown in the output? And I'm sorry, we already did that. The answer to that was yes. We're down here on router 2. No, it's because it's passive. So on that gig interface on router 2, no, we're not sending hellos. The interface has been placed in the passive state. It says use the command prompt on PC2. Can I ping the serial, and this is an interesting request, the serial 010 address on router 3? And so we're going to have to go back up and get that. Router 3's serial 010, 192.168.10.10. So it's on this network right here. So let's see why they're asking us that. And can we ping it? Okay, is it successful? It absolutely is, because router 2 is my default gateway, and it is directly connected to the network segment and this interface in particular that I'm trying to ping. Now let's go to router 3 and verify OSPF configuration information on router 3 here. It says issue the show IP protocols command. And it says router 3 is routing for which networks. And we can see the 3 networks all in area 0 that router 3 is routing for. The 192.168.1.0 is its LAN segment. The 10.4 is its directly connected transit network between router 1 and router 3. And for the 192.168.10.8, that is the transit network segment to which it's directly connected between router 3 and router 2. And so this is a great way to check to see what networks is router 3 actually routing for. Now let's enter the show IP OSPF neighbor detail command, show IP OSPF neighbor detail command here. And for router 3, I'm going to stretch our output here just a little bit. And now we see everything. It says, what is the neighbor priority shown for the OSPF neighbor routers? And you can see here that this is a great way to see that the priority is 0, but the state is full. Now, this gives us a lot of information on both of the neighbors. If I don't want to see all of that detail, and this would be my recommendation, if you're trying to see the priority, don't run show IP OSPF neighbor detail, because that is giving me way more information than just the priority. say show IP OSPF neighbor. And the priority value is right there in that second column. So I kind of like show IP OSPF neighbor here more than the neighbor detail. Now, if you're trying to dig in and get additional information that's not the priority, this is a great place to come look for that information. One of the things you might want to be looking at is how many state changes have taken place. This number should be relatively low because if you're changing states going from loading to full or full to down or two-way to loading, if you're transitioning through states in the OSPF finite state machine, that would be signaling to me that you've got some instability in your network. So that might be a reason to run this command. But if you're looking at the priority, if you're looking for the priority, show IP OSPF neighbor, a much more concise and better command to use. It says this value is the default. And we know that on point-to-point networks with OSPF, where there is no DR-BDR election because it's a point-to-point network, the default priority value is 0. So using the command prompt on PC3, excuse me, I'm apologizing there. I think I have a sore throat coming on. For PC3, it's asking me to ping the ISP router 64100 dot, and I cannot remember what that is. The ISP router 54.5. So we'll say 54.5, and we have full connectivity. So we've proven that that default route being originated by router 2 is working. And I've got connectivity out to that ISP network. So you'll notice my completion percentage this entire time has been 0%. Here is where that is about to change. We're now going to add the new branch office LAN to the OSPF-v2 network. You will now add the pre-configured branch office LAN, and I would have liked to have seen this activity have you configure router 4 fully. I think that would have added some additional much needed value to this activity so that you get the configuration experience here if it would have detailed what you needed to configure. But let's pull router 4 up. Let's go to the CLI. We're in privilege exec and it says show run pipe begin router OSPF. Now, this is taking me down. It says verify the network statements. And this is one of the things I don't like about this command, right? Is it says begin, right? So they want you to display the output starting with router OSPF. Well, if all I'm looking for are the network statements, remember, show run section router OSPF. That would be the command. And if you had multiple OSPF processes, and I don't know if that's going to work here, it does, okay, great. You would specifically put, or be specific and put that process ID number in there for the OSPF config section for the process in question that you want to see. So show run pipe section router OSPF 10. And that's going to show me the OSPF config section that I wanted to see. It's not going to show me everything after that because I'm not interested in everything after that. Again, I think that section filter would have been much more advantageous here to verify the network statements that are configured on the router. Which interface is configured to not send OSPF packets? Well, that's our passive interface. And again, it's the LAN-facing interface, and we now know why we don't want to send hellos out that interface. So this is where you're going to get 100 points for doing one thing and one thing only. It says using the correct Ethernet cable, connect the gig 000 interface on router 4 to the gig 01 interface on switch 3. It says use the show IP OSPF neighbor command to verify that router 4 is now adjacent with router 3. It wants to know the state, and then we're going to do some other work, but we can simply grab a straight through copper cable and go gig 00 to gigabit Ethernet 01. Now, port fast is not on the port on switch 3. So we're going to have to wait a second here, but that's okay. That gives me an opportunity to come in here and say show IP OSPF neighbor. Now, what you might typically, or what you would typically see here, it wouldn't be nothing, right? As soon as the port moves from the down state to the listening state, through down to listening, to learning, to forwarding, and we're looking at about 30 to 45 seconds. So what you would typically see here is it might be in the two-way, and there we go. So we see EX start, right? So it's transitioning through the OSPF finite state machine states, and we are now in the full state. Now it's asking, it says, what is the state displayed for router 3? Well, during the adjacency or the state process, we were in EX start. But what they're asking is they want to see, is it full? So yes, we are in the full state. And now it wants me to say, show IP OSPF neighbor. And it wanted us to run that on router 3. So show IP OSPF neighbor, and it's asking me, what is the state with router 4? Well, there's the loopback of router 4, and router 3 sees router 4 as the backup designated router on this segment. And the reason for that is router 3 had already been up and running. So router 3, if I go back to router 4, router 3 is seen as the DR because it, on this segment, this Ethernet broadcast multi-access segment, router 3 was the only router running OSPF. And so that wait timer, it waited for 40 seconds, router 3 did. When it first came up on that segment, it waited for 40 seconds and said, hey, there's nobody else here that wants to talk OSPF with me. There will be no DR-BDR election. In fact, I'm just going to elect myself as the DR. Or I shouldn't say there will be no DR-BDR election. There was an election, just nobody else was there. So router 3 declares itself the DR. And remember, it's not a preemptive process. So even though router 4 has a superior router ID value, the priorities are the same by default 1 on a broadcast multi-access segment like Ethernet. And router 4 has a superior router ID value of quad 4s, 4.4.4.4. It is not going to preempt router 3. It's going to elect itself as the BDR, or it'll be elected as the BDR. All right. So why is the state of router 4 different than the state of router 1 and router 2? Well, we know the answer to that question because router 3 knows about router 4 over a broadcast multi-access segment. How does router 3 know about routers 1 and 2? Over point-to-point segments. And so that's why the state is different. So it says, using the command prompt on the laptop, ping the address of PC2. Is it successful? Well, let's check that out. 172, and I like how the address is right there. It would have been nice to have the 64.154.5 there in the diagram. Let's go ahead and say ping 172.16.2.2, and there it is. I've got full connectivity on router 4. If I say show IP route, I'm learning that default route. I'm learning it from router 2. Well, I should say I'm learning it from router 3. It was originated by router 2, but I'm picking it up from router 3, and that is how I know how to get out there. If I were to say trace to the 64.154.5, you can see I go to 192.168.1.1, and that is router 3's gigabit Ethernet interface. I then go to 192.168.10.9, that is router 2, and then I go to 64.100.54.5, and that is that ISP. But here's my question for you. What if I want router 4, and again, we've got the 100%. It was literally the connection of the cable gave us the 100%. That's why I would have liked to have seen configuration commands required on router 4. Now, let me ask you this. How would I get from router 4 to router 3 to router 1 to router 2 to the ISP? How can I make that happen not using the bandwidth command? So the requirement is you've got to get the traffic to flow outbound going this direction, but you can't use the bandwidth command. How would you make that happen? So let me go ahead and leave the video here for just a second, give you a second, pause it, and think about that. How would you make that happen? All right, well, I'm going to make that happen right now. All we would need to do is come to router 3, and hopefully router 3 is going to allow me to go into global config and to go into do show IP interface brief. I think it's serial 001. and say IP OSPF cost, and let's put a cost of 8,000 on there. So now when I come back here to router 4, I just put a cost of 8,000 here. Very high, artificially so, but we now go from router 4 to 3 over to 1, then to 2. I'm sorry, 10.192.168, 10. I'm sorry, that takes me out to router 2 and then to, it's interesting, it's taking me to the, it's saying the .9, which is here. Oh, that might be how it's identifying it. This could be a packet tracer anomaly, but 10.5 is that interface there. I would have expected to see the 172. And again, it may be that this is a packet tracer thing going on here. But you can see we then go out to the internet. So it's the IP OSPF cost command. All right, well, that is going to do it for this packet tracer activity, a very good packet tracer activity that you will need if you sit for the CCNA exam, certification exam. All right, thank you so much for watching. Have a happy holidays, and I hope to see you in the next video.